First thing we notice, we have a metal. Nickel's a metal. We know we got an ionic compound. We also notice the ending of the second half of the name ends in IDE, oxide. So we know we got a binary ionic compound. Yes, ma'am?
What about the little Roman numeral thing?
Get there.
Oh, okay.
I'm just going through the questions. I got question 1. I found I had a metal, so I know it's ionic.
Oh, so you still have to go through the questions?
IDE, so I know it's binary.
So you still go through them steps?
Yeah, I'm still using them. It helps me track, and kind of help me figure out how to write the formula. I know I got 2 elements. I got it's binary. Next thing I notice is that this nickel's charge, I'm told what charge it has. I'm told it has a 4+.
So it's catatomic.
So that means it will have multiple charges.
Yeah.
And therefore, I know the symbol for nickel off the periodic table is Ni. And I don't worry about whatever charges are written by Ni on the periodic table because I know what charge I'm told this nickel has, a 4+. So I put a little 4+ up there.
Mr. Coleman, are you sure I don't make your blood pressure go up?
I'm sure. In oxide, we know that's oxygen.
Well, you make mine go up.
And we can see oxygen's charge is 2- off the periodic table.
So it's
So we pull information from the periodic table and from the name, just like before. At this point, I'm ready to cross multiply again.
Can I do it? I know what it is. It's 2Ni.
And 4 times the oxygen, right?
And then it's Ni2O4.
2 to 4, and I'm going to bring them down. Ni, subscript 2, O4. Now, one more thing. Remember I said, this is ionic. If we can simplify, we do. Can you simplify 2 to 4 to a small whole?
Yes, 1 to 2.
1 to 2. So therefore, this will simplify to NiO2.
Yeah, 2. My fault.
NiO2.
What happens if
this is therefore the correct formula for nickel 4 oxide.
Now, what happens if you don't simplify? It's still the same.
You have not shown the correct formula for the ionic form, the ionic compound.
So if I can simplify.
Ionic compounds, you must simplify.
So if
you don't, it's not correct.
So if I can simplify every single one, I got to simplify it? Or is it just
simplify ionic. You do not simplify molecular. If it's molecular, you do not simplify.
So everything that's ionic, I'm going to have to simplify. Okay.
Only simplify ionic.
Mr. Coleman, why are these so much easier than the other ones?
And what?
The ones with the H2F2, or HG, my bad, HGF2. Those ones seem harder.
There you were starting with the formula and figuring out the name. See, now we're doing the exact opposite.
I know, but the formula to the name sounds harder.
You already learned how to walk forward, so if you already know how to walk forward, walking backward is not that hard.
Walking backwards is way much easier, though, Mr. Coleman.
Well, good.
I don't trip when I walk backwards.
More.
See, when I walk forward, I can trip over everything, but when I walk backwards, I'm just like, fine. I don't trip over anything.
If you prefer to see where you've been instead of where you're going, walk backwards. Now.
What?
Number 12, calcium acetate. The name is calcium acetate. Once more, we recognize we got a metal, so we know it's ionic. But notice the ending is not IDE, so we know it's not binary. So if it's not binary, you immediately know
it's a polyatomic.
Ionic.
Yep, I see. I even knew what it was, Mr. Coleman. You don't let me finish my words, though.
So calcium, and then we need acetate. Acetate is C2H3O2. And I know that's not the way it's written. C2H3O2. I know that's not the way it's written on your sheet, but you might want to write it like this because this is how you
Jesus criminy, Mr. Coleman, that was a bunch.
So you might want to put the way I just wrote it somewhere on that sheet by the way they've written it, because you're going to see it like this a lot of times, instead of the way it's written there. So, at this point in time, I've got the charge for calcium. That came from the periodic table, 2+. The acetate is from the table there. It's a 1-. I'm going to cross multiply like before. I got 1 times the calcium, and I've got 2 times the acetate.
Really?
So far, I've done everything like before. Multiplied everything. 1 of these, 2 of these. But at this point, I'm going to add a little extra step. When I bring these down, when I bring it down for the calcium, and it's an understood 1, but I'm going to put the 1 there anyway. You don't have to show the 1, but I'm going to put it there anyway. I got 1 calcium. Before I bring the 2 down for the acetate,
do you have to multiply them all?
Before I bring that 2 down, I'm going to put parentheses around it. Because if I don't, and I bring the 2 down, I'm going to have it looking like 22 oxygens. And that's not what I'm saying up here. I'm saying I got 2 of these whole things.
Mr. Coleman, this is...
So I had to put it in parentheses before I brought the 2 down. Otherwise, it would look like I got 22 oxygens.
Mr. Coleman.
Instead of having 2 acetates. Yes, ma'am.
this, see, that just confuses me.
Once more, everything I've done here, I've done before. You had no confusion. At this point, let's see if we can clarify the confusion. If I did not put parentheses around the acetate before I brought this 2 down, the 2 would be right after that 2, and it looked like I had 22 oxygens.
The 2 that you have from when you cross multiplied, you put
2.
parentheses around the big.
I put it around the acetate before I bring the 2 down.
Okay, so
That way I'm saying, like I'm doing right here, I've got 2 of the acetate.
so if there was like 4 of the acetates, I'll do parentheses around the big thing, kahuna, and then put the 4.
If this was a 4, you would still put parentheses around it before you brought down the 4.
Okay.
Or 3, or whatever it was.
Okay, Miss Coleman, I got it now. It just took me a little bit.
And of course, 1 to 2 will not simplify, so I'm done. 13, iron 3 nitrate. Once more, we recognize we have a metal, iron. Put Fe. I am told the charge iron has with that Roman numeral, 3 plus.
Fe3.
Nitrate, I know I do not have a binary. I have a polyatomic anion, ending ATE. So I go and look up nitrate on the table. Nitrate is NO3.
NO.
Charge 1 minus from that table.
O3 negative.
So all this came from this handout sheet right here.
Yeah, that's too much.
Next point, I'm going to cross multiply. 1 times the iron, 3 times the nitrate.
Hold up.
Just as I've done before. Cross multiply. The numbers,
So
not
it's
the charge.
FeNO3.
So I got 1 iron, 3 nitrate. That's what it's telling me.
Can
1 iron, 3 nitrate.
So it would be Fe parentheses NO3 in parentheses 3.
That's correct.
Yay, I get this, and it's so much easier than doing it forwards.
So therefore, there's your formula for iron 3 nitrate. Cannot simplify 1 to 3 as simple as it gets. So you're done.
Well, actually, it could be ones, because 1
1 to
can.
3 is the simplest you can get. You got to do whole number now.
Because 3 and 3 can go into each other once, Mr. Coleman. You can
Whenever you
simplify
divide
that.
this number by, you must also divide this number by, and of course it has to be a whole number that you get.
It would be 3. You would divide everything by 3.
If I divide a 1 by 3, I do not have a 1. I have a 1/3. 1/3 is not a whole number.
See,
It must simplify to a whole number.
I'm confused. How would you? I don't know.
It's nothing confusing. You can simplify if you can simplify to smaller whole numbers.
So you would.
Otherwise, don't.
You would have to simplify the Fe number 2.
The point being, there's nothing to simplify. It's simple as it gets. 1 to 3, you can't go any smaller.
I know, but I'm saying if you could. I'm confused. How would you do it if you could?
If this was a 3 and this was a 6, you could divide both by 3.
Oh, so you're not going to simplify the number inside the parentheses?
No,
you're
ma'am.
trying to simplify the
You
numbers
only
that are out of the
simplify
parentheses.
The subscript.
Okay.
You cannot touch this. That is the nitrate. You can't change that, and you're changing nitrate. And then you're changing the whole compound.
See, I didn't know that. I thought you were trying to simplify the
We're
3 and
only
the 3s.
simplifying subscripts, as before. We're only doing what we've done before. Simplifying subscripts when we can.
Okay. What? How will you be giving me money?